In this video, in this lecture, we'll discuss or solve some problems in wave propagation. Some problems in wave propagation. So let us solve the first problem. Determine the critical frequency of an electromagnetic wave for uh, E layer where the electron density it is n is equal to 4 into 10 to the power of 5 electrons per centimeter cube, and for F1 layer the value of n is 2 into 10 to the power of 6 electrons per centimeter cube, and similarly for F2 layer the value of n is 3.5 into 10 to the power of 6 electrons per centimeter cube. Okay, so this is the problem. You want to find the solution for this. You want to find the solution for this. Okay, so in this entire wave propagation, okay, so we have derived the formula for a critical frequency. So the formula for critical frequency. Okay, so Fc is equal to 9 root n, where here n indicates number of electrons per cubic meter. Okay, let us take for E layer. For E layer, what is the value of n? They have given 4 into 10 to the power of 4 electrons per centimeter cube. Let convert into meters per cubic meter. What is the relationship between 1 meter is equal to 10 to the power of 10 square centimeters, or 1 centimeter is equal to 10 to the power minus 2 meters. Okay, so if I substitute here 1 centimeter cube is equal to 10 to the power of minus 6 meters. Okay, so the value of n is equal to, it becomes 4 into 10 to the power of 5 into 10 to the power of 6 per meter cube. Okay, this is the value of n to convert into meter. So therefore Fc is equal to 9 root 4 into 10 to the power 5 into 10 to the power 6. Okay, so if we substitute, we will get the value of 5.6 megahertz. Okay, so the critical frequency for E layer, the frequency for E layer for the value of an electron density E 4 into 10 to the power of 5 per centimeter cube is 5.6 megahertz. Okay, 5.6 megahertz. Similarly for F1 layer. Okay, so similarly for F1 layer. Similarly for F1 layer. So the expression for F1 layer, what is the value of n? They have given it is 2 into 10 to the power of 6 per centimeter cube. The same thing if we convert into 10 to the power of 6, okay, per meter cube. Therefore Fc is equal to 9 root n, that is 9 root into 2 into 10 to the power 6 into 10 to the power of 6. Okay, so we will get 1.72 megahertz. 2.72 megahertz. Okay, so this is for F1 layer. Like this, you can do for any layer. This is how we can calculate the the critical frequency for different layers present in ionospheric layer. Uh, ionospheric wave propagation. Ionospheric wave propagation. Okay, so let us solve the problem. Okay, so let us solve the another problem. So, for example, the another problem. They may ask, so what the different formulas we have studied for, okay, let's solve on the problem. So, a VH of communication, a VH of communication is to be established between, is to be established between, is to be established with, is to be established with 35 watt transmitter at 90 megahertz. At 90 megahertz. Find the distance. Find the distance up to which the line of sight communication to which the line of sight communication the line of sight communication may be possible if the the height of transmitting and receiving antenna are 40 meters and 25 meters. Also determine field strength at the receiver end. Also determine field strength at the receiver end. Okay, so this is the given problem. Okay, let us solve this. First, write the given data. So the power they have given the power is 35 watts, and the frequency they have given it as 90 megahertz. Height of transmitting antenna 40 meters. Height of receiving antenna is 25 meters. Okay. So what is the first thing they have asked? Calculate the separation distance. So see here, this is my earth surface. So this is my transmitting antenna HD. It is 40 meters. And this is my receiving antenna RX. This is my receiving antenna RX. You want to calculate. So you want to calculate this line of sight distance T. Okay, so we want to calculate this line of sight distance T. Okay, so already you have calculated the formula for line of sight. The formula is D is equal to the formula for D you have calculated it is 4.12 into root of HD plus root of HR. This is in kilometers. Okay, so simply substitute 4.12 into root 40 plus root 25, that is in kilometers. So D is equal to, we got 46.66 kilometers. So the line of distance, the LOS between transmitting antenna and receiving antenna is 46.66 kilometers. 46.66 kilometers. Okay, so what is the other thing they have asked in this problem? Determine this problem. They have asked the other thing, that is determine the field strength. Okay, field strength that receiver at. Okay, so already you had read a formula for field strength. The field strength at receiver end is equal to 88 into root P into HD into HR y lambda d square volt per meter. Okay, so this is the formula we have already derived for electric field strength. Electric field strength at receiver end, that is root 8. What is this root P? Root P is effective power. Okay, so they have given the value of P as, they have given the value of P, they have given the value of P as 35 watts. They have given the value of P as 35 watts. Okay, so simply substitute here. So here lambda, what is the frequency they have given? The frequency they have given 90 megahertz. The frequency is 90 megahertz. What is the value of lambda? Lambda is equal to C by M. What is the value of C? Velocity of light 3 into 10 to the power of 8. It is 90 into 10 to the power of 6. So it is 10 by 3 meters. So 10 by 3 means 3.33 meters. Okay. So simply substitute all these values. Therefore, ER is equal to 88 into the value of P. It is root 35 into what is the height of the antenna? 40. What is the height of the receiving antenna? It is 25. What is the value of lambda? Lambda value is 10 by 3 or 3.33 into what is the distance? In the previous case, I have calculated the distance. It is 46.66. 46.66 kilometers. Okay, so 46.66 into kilometers. So that's why I'm multiplying with 10 power 3 whole square. So if I calculate this, the total electrical field, what you are receiving end, it is 71.71 volt per meter. Okay, so this is how you can calculate the line of distance D, line of distance D, and total electrical field strength. Total electrical field strength. Okay, so they make me another problem. So let us revise what the different problems we have studied or discussed in this entire wave propagation. The first one is critical frequency. Critical frequency nu is equal to 9 root n, where n is number of electrons per cubic meter, per cubic meter, cubic centimeter, cubic centimeter. Okay, so the critical frequency Fc is equal, sorry, the critical frequency Fc is equal to 9 root n. And similarly, another formula for modulation index mu is equal to root of 1 minus 81 n by so Fc square. Okay, or F square. So under modulation mu is equal to 1 minus 81 by Fc square. Okay. So similarly, we have calculated the formula for maximum usable frequency. What is the relation between maximum usable frequency and critical frequency? It is Fc times secant I. Fc times secant I or 3.6 Fc. 3.6 Fc. This is the relationship between uh, maximum usable frequency and critical frequency. Okay. So other formula for maximum usable frequency, we have to write it is Fc into root of d by 2h whole square plus 1. Okay. So d by 2h whole square plus 1. Okay. So what is this D? D is the separation distance between transmitting antenna and receiving antenna. Okay, height H is height above the earth surface. So similarly, another formula I have calculated, that is D skip distance. Skip distance is equal to 2H into root of F naught by Fc whole square minus 1. Okay. So we may get any problem. Okay, so they may ask they will give the value of Fmop and Fc and a height. Okay, they may ask to calculate D skip. Okay, so by using this formula, you can calculate this. By using this formula, you can calculate this. Similarly, coming to the troposphere. Okay, so the line of sight distance D is equal to, so we have calculated that is 4.1 into root of HD plus root of HR, it is in kilometers, and electrical field strength, that is 80 would be HD HR, the HD HR by lambda d square. Okay, so these are the formulas you want to keep in mind while solving. You may get any problem. Okay? You may get any problem using this formulas. Okay, so you should be able to solve all these problems using this formulas.